predictive analytics. So I've already shared a little bit about this. Predictive analytics is kind of, well, it's my passion actually. It's the whole area of being able to collect data, but not just the log data, not just the readings, but now what can we do with all of those data sets? What are all the things that are coming along? So let's look at some of the technology, some of the trends right now. So one part is we've got this buildup. We've talked about the world of EAM in the past. We've added mobility to it. We've added IoT sensoring to it. All right, now what happens is you start creating those building blocks. We start getting more and more data. So the growth of the data resources is coming in. What else? Well, not only that, but I mean, I talked about this back in 2001, 2002, is the aging infrastructure. Talked about it then. Guess what? 20 years later, 15, 18 years later, it's still aging. And have we done all of our preventative and predictive maintenance programs? Have we done a massive rehabilitation of the infrastructure? Nope. So it had about 20 to 30 years of life back then, and now we're running down. It's got 10, 15, maybe 20. It's starting to go through, and we've got this massive portfolio of aging infrastructure, bridges, roads, potholes in the roads, pump stations, transmission grids, all of that stuff is aging. And there's a whole challenge that we have of trying to go through and predict when it's going to fail, what we need to do, how to optimize the program to go and do rehabilitation. Not only that, but new regulations are coming down. We have climate change. We have these major weather events, fires in California. We have hurricanes coming up from the Gulf of Mexico and through the on the Atlantic. We're seeing more and more major events in the Pacific right now that are starting to attack and hit us in the North American market. We're starting to see the temperatures rise significantly. So how does that going to affect us? What we really want to understand is predicting weather events. We want to be able to overlay the prediction of the weather events on our infrastructure. We want to be able to look at things like the predictions of all of these data feeds and understand whether our populations are using and increasing their services, or are they decreasing their use of our valuable resources. All of that within a world of shrinking budgets. So if you start looking at these two balancing, it's a complicated balancing act of trying to understand how much money I have available, which is decreasing, looking at all these externalities, climate change, forest fires, and all the impacts that they're driving, looking at our portfolio of assets and how do we manage it all, and then looking at all these data coming in that we can now look and say, all right, if I overlay all these data feeds on top of it, how do I start optimizing? So the key thing that we start looking at is that's where predictive analytics comes into play. So how does it apply to enterprise asset management? Well, if we now have all of this data coming in, we now have all of these different pieces coming along, we can start looking at field crew scheduling. Instead of going through and just scheduling it nightly, we have dynamic scheduling mechanisms. We can optimize the travel patterns of the crews within certain areas and overlay current transportation and current traffic flows within the area to optimize the run times and the travel times between sites so that our field crews are working in certain regions on certain days and basically being able to get from job site to job site in 10 minutes instead of having to drone travel an hour in high traffic zones during the regular workday. So there's a whole area of being able to go and look at that. Also being able to go through and predict what's going to happen in the next 2 days and be able to decide, should we really be going through and doing our hydrant flushing program or our mainline flushing program during a massive downpour of rain? Let's try and schedule some of our work when we see certain weather patterns happening so we can basically drive it at the same time. So it all comes into field and work scheduling and how we can use all of this different data and predictive analytics to go through and help us to do better crew scheduling. All right, what else? Well, we can also start looking at our reliability, our asset reliability. So things like, you know, as I always look at predictive maintenance programs, I think of, all right, if I've got an asset and it's a high risk asset, a pump in a pump station that's pumping fresh water to a house is more important than a pump that's delivering water to a fire or to a fountain. So it might be the same pump, but if I want to look at the reliability, I need to create criticality of my assets. Then I want to go through and look at the reliability and the risk of failure. And I can start using that metric and that method of identifying, classifying, and ranking all of my different assets. And I can use predictive analytics to basically put in a more preventative program on certain asset groups and more of a reactive maintenance program on other asset groups. But that requires a very complicated predictive analytics engine. So we do that today. We basically have these optimization services available to go through and do that. And so these techniques and these methods are all in place right now to go through and create an asset reliability program. All right, what about system performance? So I look at portfolios of assets, and a simple asset group is easier to define a maintenance program on. But what about a system? What about a system which is like a complete water distribution network? What about a massive that's overlaid with a water collection system that has overlaid on top of it its energy consumption patterns and how much energy is being used to do the lifting in the waste systems and the pumping on the water systems? Okay, so there's an integrated system now of a performance of looking at the cost of power to go and do all of the running of these pump stations and lift stations. There is a flow pattern of what demand we're getting in the way of how many people are flushing the toilet tomorrow, how many people are going to be going through and turning on their showers in the morning, so we can look at the demand profiles. Now that's the overall system model. And should we be using different ways of going through and bringing our different commodities in different areas for the high demand periods and being able to go through and do localized power gen, as an example, inside a pump station so that we can basically be driving that at the same time? That is overall system performance. Those are things of the future where we start looking not in silo at one area and one portion of it, but we always look at this concept of an integrated intelligent city. And a city has transportation networks, water systems, wastewater systems, building portfolios, park networks, people moving around, vehicles moving around, transportation grids moving around, and electricity being used to go through and move all of that. How do those systems interact? Well, in an enterprise asset management, we're the main collectors. The EAM in a city scale environment is the primary repository of all the assets. The GIS system is the mechanism that is overlaid on top of that to basically go through and model and show where they're all located. When we start looking at predictive analytics, we then start looking and say, now, can I start taking all the reading data I'm getting from my sensors, from my meters, and my SCADA systems, and can I start now looking at the overall systems and how they're performing relative to each other? That's the future that we start seeing with enterprise asset management and the use of predictive analytics for enterprise asset management.